So here on question 12 it's asked us to draw a box plot. We know the minimum or the least height is 154, so we can plot the end of our whisker. The median is 165, that's the middle line inside of our box. The lower quartile is 161. So that's the end of our box. The interquartile range is 7, so therefore our upper quartile must be the lower quartile plus the interquartile range, which is 168. So now we could draw in our upper quartile. We can connect our box to our lowest, and then the range is 20, so therefore our max must be our lowest plus our range, which is 174. Again, we can draw that in and then connect up our box. It doesn't matter the size of your box plot, I've just done it to the end of the graph. So here in part B, it asks us to compare the distribution of heights for Year 7 girls and Year 11 girls. Well, we know we need to compare our medians and then our interquartile ranges. Our interquartile range for the top box plot was 7 and our median was 165. And then for the Year 7s, our median result was 157.5. And then our interquartile range goes from there to there, which is 10.5. So now we've got our figures, we can compare our box plots. So the median for Year 11 girls is 165 compared to 157.5 for Year 7. On average, girls are taller in Year 11, and then also the interquartile range for Year 11 is smaller than the IQR interquartile range of Year 7, suggesting there is less spread results in Year 11. So the results are much closer together because the interquartile range is smaller, so the data is less spread out. Okay, so in question 13, there's 450 pies made every day. He's taken a sample of 15, and that the proportion that he takes is the proportion that were made. And on Monday, he counted that he needed exactly 4 chicken pies in his sample. Well, we know if we wanted to get a sample size, it would be however many chicken pies there were, which we don't know, divided by the total amount of pies made that day, which we do know is 450, multiplied by the sample size. And that, he has told us, the answer to that calculation is this 4. So we need to work out what that question mark is. So in order to do that, we're going to call that question mark X. So we're going to simplify this before we calculate it. So we can actually cancel down on top and bottom of our fraction. So we can rewrite this as 15x divided by 450 is equal to 4. Might make it a bit easier to then spot that we can cancel down this 15 with this 450. 15 goes into 450 30 times. So then I'm left with x over 30 is equal to 4. Now I can multiply both sides by 30, and that would give me my answer of 120. The reason I cancelled these down was just because I could use lower numbers. Okay, I could have originally times across by the 450, then divided that whole thing by 15, which is what I imagine a lot of you did, but it just avoids having to do too much maths, when actually we could have cancelled down straight away and then got slightly nicer and easier numbers to work with. So in part B, it says on Tuesday, the number of steak pies he needs is 6, correct to the nearest whole number. He then takes a random pie from the 450 he made on Tuesday. And it wants the lower bound that the probability is a steak pie. Well, straight away, because we're talking about bounds, we need to write down our lower bound of 6 to the nearest whole number. So our lower bound is going to be 5.5. We can also write down our upper bound, but we're not going to use this. But your upper bound would be 6.5. That already has guaranteed you 1 mark out of the 2. Then we do a very similar approach as to above. So we don't know how many pies there are, but we know there's 450 in total. He takes a sample of 15 every day, so therefore we times that by 15, and this time we got the answer 5.5. Now we again cancel our fraction. So that leaves us with y over 30 is equal to 5.5. So y must equal to 5.5 multiplied by 30. This is equal to 165. So we now know there's 165 steak pies. So the probability of picking a steak pie would be 165 divided by the total amount of 450. It doesn't ask us to simplify, so we're going to leave our answer there. So on question 14, we are told this ratio y plus x to y minus x is equivalent, so is equal to this k to 1. So if we start with that original ratio, y plus x to y minus x, I want to get it in a form so that our right hand side is 1, so that we can compare it to this equivalent ratio up here. So to go from y minus x to 1, we have to divide both sides by this y minus x. So we need to divide this side by this y minus x as well. So therefore we would have the ratio y plus x divided by y minus x to 1. And we know that that is equal to this k to 1. So because they're equivalent, we can just have a look at the left-hand side of our ratio. So the left-hand side of this ratio was our y plus x over y minus x, and that has to equal to the left-hand side of this second ratio because they're equivalent. So that is equal to k. Now we need to rearrange this equation so that we have y equals. So my first step is to times across by my denominator. I then expand my brackets. I get everything to do with y on the left hand side, everything else not to do with y on the right hand side. So then I'd be left with negative kx minus x. So what I've done is I've took my ky to the left hand side by subtracting it, and I've took away my x from the left hand side by subtracting that. Now the only way we can go from 2 y's to 1 y is by factorising. So we factorise out the y. That leaves us with 1 minus k inside of our bracket. And then finally, to work out what y is, we divide through by the bracket. Now at this point here, you'll notice that the show that form is slightly different to ours. You'll see that all the signs are actually the other way around. So we can very quickly reverse that. If we flip all of the sides on the right hand side, it will not change our question. So kx plus x over k minus 1, and then the last bit they've done is they have just factorised out the x on your numerator. Now we've got to exactly that form which it wanted us to show. Question 15, again, is a question all of you can do. Times it by 10, so we get our reoccurring part lined up to our decimal place. Times it by 10 again. And then you'll realise that your reoccurring parts are not lined up, so we need to times it by 10 again. That will give us 436.36. Now our recurring parts are lined up, we can subtract these away from each other, and you'll see that those recurring parts disappear. So 1000 take away 10 is 990x, 436 take away 4 is 432. So therefore x is equal to 432 over 990. Now you can simplify this fraction. If you're confident with your answer, then in your exam you can just write equals 24 over 55, because that is what the answer is told. Question 16, y is directly proportional to the cube root of x. So again we set out our table. Y is 1 and 1/6, so I'm going to rewrite that as 7 over 6 when x is 8. The cube root of 8 is 2. So the tricky part here is spotting the link. How do you go from 2 to 7 over 6? Or how do you reverse? How do you go from 7 over 6 to 2? So if we were going from 1 to 7 over 6, we would times by 7 over 6. So because we're going from 2 to 7 over 6, we just need to half our numerator. So it would become 3.5 over 6, because 2 times 3.5 is 7. So this is equal to timesing by 3.5 over 6. We don't like having decimals and fractions, so we would change that to 35 over 60, which actually we can simplify to 7/12. So we're timesing by 7/12. Find the value of y when x is 64. So now we put in 64. The cube root of 64 is 4. 4 times by 7/12, well, that is equal to 28 over 12, which is 14 over 6, which is 7 over 3. Any of those answers, because it doesn't ask you to simplify, would be fine, and also 2.3 recurring is also fine. Okay, question 17. It wants you to prove algebraically that the sum of these two things is always a square number. So we've got 1/2 n times n plus 1, add 1/2 n plus 1, n plus 2. So I'm just going to look at the left-hand side to begin with, and I'm going to multiply out my brackets. 1/2 n times n is 1/2 n squared. 1/2 n times 1 is 1/2 n. Now I'm going to deal with my double brackets, and then I'll half it all after. So my double brackets gives me n squared plus 3n plus 2, and now I'm going to half each of those, so 1/2 n squared plus 3 over 2n plus 1. And then that was added to our original left-hand side. Now we can collect together our like terms. We're going to have 1n squared plus 2n plus 1. So now, if we can factorise this into double brackets to show that it has to be a square number, we would get n plus 1 squared, because this would factorise to n plus 1, n plus 1. So because we have factorised it into this squared bracket, it must always be a square number. Whatever n value you have, you are squaring it, so it will always be a square number.